Hi everyone, and welcome. This video will detail how Seequent solutions will streamline your structural modeling. I'm Andrew McLaughlin, Product Manager for Geology based in Christchurch, New Zealand. I'm really looking forward to sharing some of the exciting updates in this release of Leapfrog. In the latest Leapfrog 2025.3 release, we've taken structural modeling a step further, giving geoscientists more powerful tools to explore and interpret their data with greater precision. Whether you're working on infrastructure projects like tunnels or tackling the challenges of complex mineral systems, understanding structural controls is key. This update enhances your ability to visualize those controls in 3D, uncover hidden patterns, and make more confident, informed decisions based on the geologic data in front of you. In geologic modeling, clarity and control are important. That's why we've made powerful updates to how the structural trends are handled, giving geologists more precision, transparency, and insight. First, structural trend clustering has been moved to downstream models. This update provides clarity that the clustering is applied to the input data of the model. Feedback has indicated some uncertainty in this area, and this improvement should provide clarity around when the clustering is applied while building the model. Clustering settings are now visible in the Model Setup dialog when a model or surface uses a structural trend. No more guessing. Now you can see exactly how trends are influencing your model, making it easy to audit and adjust. Clustering is now expressed as a percentage. The total number of inputs into the clustering step is also included in the settings, helping you fine-tune your model with confidence. We've taken structural trend modeling even further, adding powerful visual and workflow enhancements to make clustering more intuitive and actionable. Now cluster ellipsoids can be visualized directly in the scene. This gives you a clear spatial understanding of how clusters are distributed, helping you validate and interpret geologic structures with confidence. Input points for models or surfaces can now be colored to their cluster. This visual cue makes it easier to spot patterns, anomalies, and relationships at a glance. And finally, clustering objects are now present in the project tree for downstream models. This ensures the changes you make to the clustering settings are immediately visible in the project without the need to extract points. Stereonets are essential for structural analysis, and now they're more powerful than ever. With new filtering, color control, and a redesigned interface, you'll get clearer insights and smoother workflows. You can now filter stereonet displays using both numeric and category data. Whether you're isolating specific orientations or focusing on geologic units, filtering helps you zero in on what matters most. Color maps changes can now be made during category selection, giving you full control over how your data is visualized. Finally, the stereonet user interface has been reworked for better outcomes. It's cleaner, more responsive, and designed to help you get to results faster with less friction. Let's look at these workflows in action. We will look at a numeric model and the settings for the clustering. Here we have a numeric model in Leapfrog indicating gold distribution. There are clearly two directions of structural controls present within this data. With Leapfrog structural trends, we can remodel this isotropic distribution to utilize structural information to produce a more geologically realistic distribution. This model is influenced by a structural trend, which we can see visualized here. This trend is influenced by the fault, meshes, and other structural information found within the project. The structural trend is influencing the output volumes to produce these shapes. The settings for clustering are no longer found in the structural trend dialog, but rather in the Model dialog under the Trend tab. We can see from the dialog here, the structural trend is selected and the relevant clustering settings are displayed below. Things to note from this dialog is that the clusters are now represented as a percentage of the input data, and the total number of input points for the model are listed here, as these are the values we are clustering. The clusters can now be visualized as ellipsoids in the scene. The ellipsoids are a representation of the cluster anisotropy. Clustering takes the input data and divides it into a grid based on the minimum cluster size. If adjacent clusters have enough consistency, they will be merged into larger clusters until the maximum cluster size is met. Or more commonly, the adjacent cluster is no longer consistent enough. All these settings can be controlled within the dialog here. The input data can be visualized by cluster. This is done by selecting the coloring from the scene list. This will show the clusters given to each of the input data points. The clusters, along with the anisotropy represented by the ellipsoid, will give a clear indication of how the trend will be influencing the resultant volumes. The ellipsoids and the points share a color map, allowing us to interrogate single clusters. We can see here that this cluster is affecting the model with the matching anisotropy of the ellipsoid as well as the volumes present in the scene. In the next example, we are looking at a different iteration of the model, where I have increased the consistency threshold, which will require more consistency between the clusters and isotropy. We can see that there is far more clusters produced in this iteration. Overall, these clustering settings will help control the resultant model and give us a far better result when compared to the isotropic model initially produced. Before we wrap up, let's quickly recap the key improvements in Leapfrog 2025.3 that make structural modeling smarter, cleaner, and more powerful. Structural trend clustering has been streamlined for clarity and control. It's now applied to downstream models, with the settings visible and expressed as percentages, so you know exactly how trends influence your model. Plus, cluster ellipsoids and color-coded input points give you clearer spatial understanding of your data. Stereonets have received a major upgrade. You can now filter displays by numeric and category data, adjust color maps on the fly, and enjoy a redesigned interface that's clearer and more responsive, helping you get to insights faster. Overall, these enhancements give you more precision, transparency, and confidence in your geologic interpretations. More control, better insights, and workflows that just make sense. All that's left to do now is upgrade to the latest version of Leapfrog and try out these new workflows. Thank you for watching.